Alright, we've got a limited amount of time. You're allowed. I'm going to keep going, and you're fitting for yourself on your homework. Okay. A vector is very similar to a polar coordinate, except a vector looks like this. Oh, that's not what I wanted to do. One of my line drawer thingies. There we go. A vector has both magnitude and direction, which basically means it has, just like a polar coordinate, both a certain length and a exact, it's traveling in a certain way. Like this one, 11 pi over 6. What is that? What was this angle? Like 210 degrees? So this vector, here's how the only difference between vectors and polar coordinates is instead of giving it like this, I would say this vector, which I would label, which I'll label in a minute, I would say is traveling, let's see, is it more eastward or westward? And would it be south or north of west? South. So you would say it's traveling about 30 degrees south of west, 2 units. South of west? Yes. Vectors are basically used in navigation. You'd say how far you were going and what direction you were going. And in this class, we're always going to be using north or south of, east or west. Your second one, will always be east or west so that we can stick with our x-axis. We kind of like doing our x-axis. So you're always going to go in reference to the eastward or westward. So, let's say this vector started at, I don't want to do it like that. Let's say this vector started at point U and ended at point V. This would be vector UV with a little Robin Hood cap. Now the order matters. The feather in the cap has to go above the terminal side. Much like an angle, you have an initial side and a terminal side. Guess what they stand for? The initial side is where it initiates, where it starts, and the terminal side is where it stops or terminates. So initial side and terminal side of a vector. Now, unlike a ray where the arrow implies that it keeps going, a vector does not keep going. It stops. So you're thinking, why the arrow? Well, without the arrow, you don't really know. If I were to just show you a vector without an arrow, you wouldn't know whether it was going northeast or southwest. So the arrow just tells us it was going this direction, south of west. The only reason a ray has an arrow. Only one whatsoever. For two rays to be congruent, in exercises 1 through 4, U and V have the same direction because they're going in the same angle. Thank you, yes. In exercises 1 through 4, U and V have the same direction. A, find the, now see this double absolute value? That means magnitude. Find the magnitude of U. Magnitude is nothing more than length. So, given 2 points on the coordinate plane, how are you going to find the length? Distance formula. Distance formula. Way to go, Chris. That's right. You're going to use the distance formula. So, distance formula. x2 minus x1. Those are my y values. Well, I'll just do those first then. y2 minus y1 squared plus x2 minus x1 squared. So that's 16 plus 25. What is that, 41? So U has a magnitude of 41, a radical 41. The absolute value of, these little symbols mean magnitude. That is the magnitude of vector U. You think so? Well, let's see. Doing the magnitude for vector V, so that's 5 minus 0, 4 minus 0, yeah, 25, 16, let's just jump the gun. You're right, it will be radical 41 for V as well. I should. But then again, you say so much. My filters turned up. Okay. Okay. Now, for two vectors to be equal, it says, is vector U equal to vector V? For two vectors to be equal, they have to have both the same magnitude and the same direction. They don't have to start in the same place, but they have to have the same magnitude and the same direction. So you can have infinitely many equal vectors. You could have one here, 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 here. It doesn't matter. As long as they're all traveling at the same degreeage northeast as the original one was, and as long as they all have the magnitude radical 41, they're equal. questions about how we concluded those were equal or anything that I've just said? Just the length. Magnitude is just length. Yep, exactly the same. Other questions about anything from this slide? All right. Next slide. Are those two vectors the same? Let's just somebody raise your hand and tell me. What do you think? Are they the same or not? Hey. Kelsey. Yes, they are. They're both going the same direction. Now you could have done distance formula, but since they're going just straight, you could count it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes. They both have the same direction going due east, and they both have the same magnitude of 6. That's, yes. If the bottom one had an arrow going this way, they'd not be the same. Because one's going east, the other's going west. Yes. Where they start and where they end is irrelevant when you're talking about equivalent vectors. They could have started here, 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 here. Doesn't matter. All we really care about are they going the same direction and are they the same length? Good question. Starting point and ending point do not matter. Other questions? Marching along. All right, an exercise. Okay. Vectors are written down as a sum of unit vectors. What does that mean? Well, I'll show you. Let's look at number 5. 3i plus j. If you were to graph 3i plus j, here's what it would look like. Do I have graph paper saved? I don't think so. Well, I'll just draw it like this. If you were to graph 3i plus j starting at your initial point, here's what it would look like. Every I is a horizontal one-unit vector. Every j is a vertical unit vector. So 3i would be 1, 2, 3 units right, 1 unit up, and your vector itself, oh, I have it on the wrong end. That's wrong. Thank you for understanding. It'll always, because it's traveling right and up. They're both positive, so then that's right. So it's going to work like on the coordinate plane. Positive I is to the right, and negative I is to the left. Positive j is up, negative j is down. So, sketch each vector, that would be number 5. Now you're sketching, so I don't know how long you want to make your units, I don't really care. As long as I see the little arrows, I'll understand that you were trying to do that. So, that's right. For number 7 to be right one, well, dang it, hold on. Right one, down one, and you're finished. Well, this is horrible. I can't do this like this. So number 7, the magnitude. You would, but you don't have to right now. All it wants us to do, oh, it does say find the magnitude, doesn't it? You are correct and I am wrong. It does ask for the magnitude. I didn't see that. Actually, there's an even easier way. The I and j coefficients, can make up what we call the component form of a vector. So for number 5, now it didn't ask for this, but number 5, that would be the component form of this vector. Right 3 units, up 1 unit. Okay, turn it up a little bit. Right 3 units, up 1 unit. All you have to do to find the magnitude is put those two numbers in the Pythagorean theorem. Because that's basically one leg and another leg of now a little right triangle. And your magnitude is just your hypotenuse. So the magnitude, you could quickly punch those into the Pythagorean theorem, and you'd find that it has a magnitude of radical 10. Well, let's see. First off, let's draw it. Number 7, right 1 unit, down 1 unit. So there's your finished product. There's your actual vector. Maybe I should change colors. Yes. Yes. Shh. Too much chit chat. Here's what he means. He means there's really no point in doing 1 squared plus negative 1 squared because the negative is just going to go away anyway. So he's saying, why not just jump the gun and just call them both positive every time? And you can. Yeah, that's it. So this would be, what, radical 2 when you solve for it? I skipped a step here. But when you solve it, radical 2 would be your magnitude. This is the sketch. This is the magnitude. Number 9. Am I going to go left or right? Up or down? All right. That's right. Left 6. down to connect your dots by changing colors for me. There's my finished product, and what was my magnitude? Radical 40 after the Pythagorean theorem. Number 11 doesn't have a vertical component, so it's just going due west. Straight line, and the magnitude would just be 4. There's only just one number, it's just going to be that number for the magnitude. 4 units. It is indeed. Questions about anything from that page? Magnitude is always positive. Questions? What? Like the polar coordinate kind of thing? No, you don't have to do that for me. You just tell me the magnitude and what degree it's going, west of south, whatever. West of south doesn't make any south of west. Okay. Yeah, you don't have to go negatives with me. Oh. All right, let V be the vector with initial point P1, terminal point V2. Write V in terms of I and J. So all they want here is the I and J equation. So if it starts here and ends here, who could tell me how many units it's going right or left by raising your hand? Kim, how'd you get that? That's right. To get your I and J equation or your component form, whichever one it's asking you for, just take x2 minus x1, which would give you 10. And then take y2 minus y1. It is important that you do the terminal side first if you're just going to use subtraction. 2 minus negative 4 is positive 6. So vector U, or excuse me, V, is 10i plus 6j. Actually, no, you can just literally, this one is just x2 minus x1, and this is just y2 minus y1. You don't have to do anything with it. X, you take the two x's and subtract them, and then that just goes with I. 10. I think it just wants it in terms of I and J. You don't have to do anything from here. That's all you have to do. Nope. It's even easier. Aaron, you want to try, give me my IJ equation for number 15? Which would be 6. And what's my J's? Negative 3? Yes. There you go. Raise your hand if you are curious about where these are coming from. It's just because we already use X and theta and Y, so they just say, hey, I and J don't get you love. There you go. Why not Q or Z? You can use Q and Z if you really want to. Okay. All right. Any questions about that slide? If you get 0 for one of them, then it's just not going to be represented. It'll be, don't bother writing 0i, just leave it out. I think that happens on number 19. There's no J, so that would just be 6 minus 9i is number 19. 9i. Any questions? Marching on. Making good time. We're already over half done. Okay. Hey, guess what we're going to do here? We're literally going to do exactly what it says. U plus V. Guess what? You're just going to add U and V. And guess how you add it? Somebody raise your hand and tell me how you think you would add it. That's right. Common thing. So U and V. 2i plus negative 3i, negative 1i. Negative 5j plus 7j, 2j. Boom. There's 21. That's it. 2i plus negative 3i is negative 1i. Negative 5j plus 7j is plus 2j. And that is vector U plus V. Good question. Oh, we'll get to that in a second. Somebody tell me how you think we're going to do number 31. Hannah, what do you think? 31. Just what? How do you think we're going to do it? That's right. I love the patronizing tone. Really makes my Monday. That's right. 3w, negative 3i minus 18j. That's 3w. Then we're going to add that to 2v, which is negative 6i plus 14j. Add them together. Negative 3 minus, plus negative 6. Negative 18 plus 14. I should have had parentheses here, I guess. Not that it'll make any difference. Minus 4j. And then for 35 and 37, all you have to do is do what's inside the equation and then find the magnitude. Like for instance, let's say 31, and that's what this, yeah. Let's say 31 had also been inside the magnitude thing. Well, you find 3w plus 2b, right here, and then find the magnitude. 9 squared plus 4 squared equals 2 squared. Yes. With your coefficient. I'm glad you think so. I love that case. They are kind of simple. Questions about anything you see on the board? Not really. Questions? No? All right. Well, that depends. I don't think so. 26 questions, but these are pretty quick. Okay, now, a unit vector. This is all you need to write down. And then write somewhere that this is a unit vector, and I'll explain what that means in a second. All right. All this is, let's go back one slide. Oh, actually, before we do that, let me show you. I don't know that it asks you this anywhere, but a common asked vector question in future classes that you're going to have, so we'll just go ahead and breach on it real quick. You may have even talked about it in geometry when you were, well, see if you're over there. Okay, when you add vectors, here's what it looks like. U is you going right, up, down, or left. Vector U, let's look at 21. Go back up here. We're going to do U plus V, but I'm going to show you what that would look like. U, what is U going to look like? Somebody just yell it out. 2 right, 5 down. So U would look 2 right, something like that, right? What would V look like? 3 left, 7 up. When you add vectors, you do what's called tail to tip addition, tail to head. It doesn't matter. Basically, you do U, and then you go to where U stops, and you do V. So about 3 left, 7 up, put us about up here. The sum U plus V starts where you started, ends where you ended. And what is that? That's about, I don't remember what it was, but let's see, the sum was left 1, up 2. Well, I didn't draw it perfectly because I was just sketching, but it should work out somewhere. Left 1, up 2 takes you to that same spot. So that's what it looks like when you add vectors. You just do the first one, add on the second one, and then connect where you started from where you ended. And that vector should match up to your actual algebraic sum. Ours is a little off because I sketched it, but that should have been left 1, up 2. And that's just what it looks like. When you subtract vectors, it's just basically the same thing, except instead of adding it, you would do the direct opposite of it. And that's where the negatives come in. You don't have to sketch today, but I wanted you to have seen it, just in case you see it in the future. It's not the first time. Okay, now, a unit vector. Let me go back. Let's look at 30. What was it, 31? 30 run real quick. 31, negative 9i. Let's see, negative 1, 2, 3. You know, all these little left, dot, dot, dot. There's number 9. And then you went down 4. So our finished vector was this one. Negative 9i minus 4j. A unit vector simply says, take your finished product and divide it into little 1 units. Well, you can't just go do right and do left and just pull it out like that. So how you would find the equation for a 1 unit vector in your direction is you simply take just what that formula said. You take your vector, so in this case, 9i minus 4j, and you divide it by the magnitude. So what is the magnitude of this one? Somebody who's good at mental math, just throw it out there. What would be the magnitude of this vector? I hear the wheels turning. The 36. Whoa. Okay, sorry, I heard so many different things. 30 to 97. So, you take your vector, divide it by the magnitude. Now if you were to rewrite this equation, that'd be negative 9 over radical 97. Yes, we are going to have to rationalize. We'll get to that in a second. Minus 4j over radical 97. And this is the equation for, you'd have to rationalize it, but to save time, I know we've been doing that all year. So this would be the equation for one unit vector in our direction. Negative 9 over radical 97, down 4 over radical 97. It's kind of ugly, but that's the formula for it. And that's all you have to do. It looks worse than it is. Yeah. Excuse me? No, but I finally figured out how to fix this one. So it was complicated. I'll explain it later. Okay. So, 39 is easy. Somebody look at 39, do some thinking, and tell me why you think it would be easy. That's right. So you're going to take your equation, which is given to you in all four of these. What's the magnitude? 6. And what's that reduced to? I. So I is the unit vector that has the same direction as your vector. That's why that one was easy. 41 a little less easy. What's the magnitude of 41? What was it? 5. You're right, when you do Pythagorean theorem. So, the unit vector for this one would be 3/5 I minus 4/5 j. That's, I don't really know how you write the unit symbol, so I'll just leave it like that. 3/5 I minus 4/5 j. Gesundheit. Questions about where any of this stuff is coming from? Yes, ma'am. Yeah, well, it'll be rationalized on your test. I don't really care if you do today or not. It's probably a good habit to get into because that's the way it'll be on your test, but I don't really care. I'm not going to take the time to mark those wrong. So it's I'll rationalize one real quick. 43. 43. What's my magnitude on 43? Radical 13. So that would be 3 over radical 13. I'll rationalize it just a second. I minus 2 over radical 13. J. Rationalized, that'd be 3 radical 13 over 13I minus 2 radical 13 over 13J. It doesn't take that much extra time. That is how it'll be on your test. Yeah, that's all I did. Just multiply the radical by top and bottom. Good. Questions about anything you see? Fantastic. We're almost done. Does anybody need me to leave this on the board for a moment? Last slide. Write the vector in terms of I and j, whose magnitude is 6 and whose angle is given. So, you're going to have to use SOHCAHTOA and some trig. So, length of 6 at an angle of 30. So, this is just like what you did in the DOM. Radius, this is basically just a polar coordinate. Think about it like this. Radius, theta. Over 6 up 30. So your vector looks like this, and it wants it in terms of I and j. Well, you know this is 30. You know this line's going to be your i's, and this line's going to be your j's. So you just need to solve for them. So we have to use SOHCAHTOA. You want to solve for I or j first? I. So we're using 6, which is which side? Hypotenuse. Which side is I? Adjacent. Which trig function is that? So cosine 30 equals adjacent over hypotenuse. What do I need to be in? What mode? Degree. Very good. So that'd be 6 times cosine 30, and you'd have your i's. Sorry, I'll get this off the board in just a second. Okay, so make sure I'm in degree mode, which it looks like you're going to be in degree mode for all of these. 6 cosine 30. Ugh, really? Thought it was prettier than that. Okay, not a big deal. Oh, you know what? Just use decimals. So 5.2i plus, what trig function are we going to use for j? Sine. Sine of 30 equals j over 6. So 6 times sine 30 should just be 3. when you punch it in. So this would be my equation. You're going to have to use SOHCAHTOA to find your i's and your j's. They'll always be cosine for I, sine for j. That's just the way it's always going to work out, because it's giving you the hypotenuse each and every time. In fact, some of you might get a tad confused if you start punching in 220, like if you try to draw a triangle of 225. So I guess an even easier way to remember this, just remember how we did it for polar coordinates. R cosine theta for your I value, R sine theta for your j value. Just remember, instead of R, these are our R values now, the magnitudes. So you can just punch that in. Questions? Okay. Thither thou goest.